The implementation of merge sort. So here we have the two method, that is merge and merge sort. So from the main method we'll call this method merge sort, and from this merge sort we are calling this method merge. So this merge sort will going to divide the array into the two equal subarrays, that is the left subarray and right subarray, and this method merge is going to merge the two sorted subarrays. So if you see here we are calling in recursion. This is my first recursion and this is my second recursion. So the subscriber who doesn't have a proper understanding of recursion, please check the backtracking topic first lecture, that is recursion. Without recursion understanding, it's difficult to understand this implementation. Also, recursion is the most important topic of DSA. Its uses almost everywhere like binary tree, graph, dynamic programming, etc. Let's come back to our problem. So here we have the two methods. So from the main method, we call this merge sort, and here we are passing the array, that is the input array that is given to me in this problem. So this array we need to sort using merge sort. So this is the array and this is the empty result. So this array is empty initially, and then we have the low and high. So the low is 0 and high is 7. That is the 0th index and the high index of this array. So this is 0 and this is 7. Of course high is not equal to 0, so it won't go inside this if statement, and then we find out the mid. So 0 plus 7 by 2, it will give me the mid as 3. And then we call the methods in recursion. So basically the first call will give me the left subarray and the second call will give me the right subarray. So in the first call, the value of low is 0, mid is 3 that we just calculated, and in the second call, this is mid plus 1, that is 3 plus 1, and the high is 7. So the first call will give me left subarray, and how we get that? Because of this call, that is merge sort array result 0 and 3. This is array result 0 and 3. And then this is my second call, which will give me the right subarray, that is array result 3 plus 1 and 7. So you need to note one point here, that this right subarray is not yet called. It will be stored into the stack because it's a recursive call. So first we need to finish this call, and then once we come back, then we need to start calling this specific method, that is the right subarray. So we first explore the left subarray, that is this one. So now when we call this method again, the value of low is 0 and the value of high is 3 here, that we just calculated, that is this is 0 and this is high, and we call this in recursion. So this will become 0 and this will become 3. Of course high is not equal to low, so we again find out the mid, that is 0 plus 3 by 2, which will give me the value of mid as 1. And then we again call these two methods in recursion. So low will be 0, mid will be 1, and for the second recursive call, this is 1 plus 1 and this high is 3. So basically the first call will give me the left subarray, that is 8 and 4, array result 0 and 1, that is array result 0 and 1, and this is the second recursive call, which will give me the right subarray, that is array result 1 plus 1 and 3. This 1 is nothing but the mid and the high is 3 right now. So of course we need to first process the first call because it is in recursion. So second call, that is this one, will be stored into the stack. It means this call will again go into the stack. It's not yet processed. So this call and this call is still not yet processed. So we are only calling the left subarray for all the subarrays that we are finding out. So now the value of low will be 0 and the value of high is 1 here, that is 0 and 1. So we are calling this method in recursion. So mid will become high and low will become 0. So high is not equal to low because low is 0 and high is 1, and then we find out the mid, that is low plus high by 2. So the low is 0 and high is 1. So 0 plus 1 by 2 will give me the value as 0. So this low is 0 and mid we just calculated, that is also 0. So we call these two recursions. This low will be 0 and mid will also be 0. And the second recursion, this is 0 plus 1 and the high is 1. So the first call will give me the left subarray and second call will give me the right subarray. So basically I'm talking about this is my left subarray, which will give me this number, that is 8, and we get this from this call array result 0 and 0, that is array result 0 and 0. And then from this call we get the right subarray, that is array result 0 plus 1 and 1. This mid is 0, so here we have 0 plus 1. So first we call this one because it's in recursion, so we first take this one, and this call, which is this one, will be stored into the stack. So when we call this method, the value of low is 0 and the value of high is also 0. So it will hit this condition, and what will happen? It will simply return it. So basically this call will simply return it, and once we return back from it, we come back to this call. Which one? This one, which we stored into the stack, that is array result 0 plus 1 and 1. So now time to call this one, that is the right subarray. So the value of low is 1 and the value of high is also 1. So in this case also low equal to high, and we simply return it. So this call will simply return it and this call will also simply return it. So these two calls is return back. So now time to call the merge, which is going to merge these two subarray. So in the merge call, the value of low is 0, the value of mid is 0 and the value of high is 1. So we call this merge method 0, 0 and 1, and this is by merge. So this will be 0, this will be 0 and this is 1. So here we are simply storing these values. So I will be low, so I is 0, j equal to mid plus 1, so j will be 1 and k is also 0. And then we simply check that is the value of I is less than mid. This is my I, and we check that it must be less than equal to the mid, and the j, that is this one, which is pointing to the first index of the right subarray, it must be less than equal to high. So of course these two conditions are equal because I equal to mid and j is also equal to high, because the value of I is 0 and the mid is also 0. So if you remember, the low is 0, mid is 0 and the value of high is 1. So I equal to mid and j is also equal to high. So we go inside this while loop and then we check that array of I is less than equal to array of j or not. So array of I means array of 0, array of 0 is 8, array of j, it means array of 1. So array of 1 is 4. So 8 is greater than 4. So this condition didn't happen, so it will go to the else part of it. And there we store the value into my result array. So currently the result array is empty. Now we store the value in the array into this result array. So this is my result array, and here we simply transfer the value that is present at array of j. So array of j is 4, so we store at index 0 is 4. So basically we are updating this result array and we store that into this result array, that is the number 4. And then correspondingly we increment the value of j and increment the value of k. So now k will point to the index 1 and we increment the value of j. So now as we increment the value of j, the value of j will become 2. So it will come out of this subarray. It means this while loop will break. And then here we are copying the all the left elements. What that means? It means in the right subarray we already store this number into the result array, and then this is done. So now we left with the this left subarray, that is the number 8. So I is less than equal to mid, so we simply copy the values from the array of I, that is array of 0, into the result of k. K is right now pointing here, so we store the value as 8 here. Then we won't go inside this while loop because the value of j is right now 2 and the value of high is 1. Why? Because here we increment the value of j. Once we copy that into the result, then we increment the value of j. So the value of j was 1, so we increment that to 2, and of course the 2 is less than equal to high. So it won't go inside this while, and then we update the main array, that is the input array. So till now in my result we got these two numbers, that is 4 and 8, and correspondingly one by one we start copying and updating into the main array. So now in my main array, previously we have 8 and 4, and now we update that with 4 and 8. That is the number that is present in the result array. So this is the merge operations in this left subarray. Now left subarray is already processed. Time to call the right subarray. That is this specific call which was stored into the stack. So once we call the right subarray, that is this specific call, the value of mid is 1. That's why it's 1 plus 1, 1 plus 1, and the value of high is 3. So when we call that in recursion, the value of low is 2 and the value of high is 3. Of course, high is not equal to low, and then we find out the mid. That is 3 plus 2 by 2, so it will give me the value as 2. Low will be 2 and high mid will be 2. So the first call will give me the left subarray and second call will give me the right subarray. So this is my first call, which is this one. So array result 2 and 2. This low is 2 and mid is also 2. And in the second call we get the right subarray, that is this one, 12. And here we have 2 plus 1 because mid was 2 and the value of high is 3. So first we process of course the left one because this is the first recursive call. So we need to first process this one. So here low is also 2 and mid is also 2. So we call that method and low and high is equal. So that's why we return from it. So this left subarray will return it. So this call will return back, and then we explore the right subarray. That is this call, 2 plus 1 and then 3. So of course low is also 3 and high is also 3. So high is equals to low. So then we return back from it. So these two calls are done. That is first left call and then the right call. These two calls are done. Time to call the merge one. It means we need to merge these two subarrays and we call the merge method. Here the low is 2, mid is 2 and high is 3. 2, 2, 3. So we need to call this method merged. So low is 2, mid is also 2 and high is 3. Correspondingly, we update the value of k, I and j. And what we are doing here? Simply comparing these two subarrays, that is left subarray and right subarray. And where we are comparing it? We are comparing inside this while loop. So array of I is less than array of j, array of I is 3 and array of j is 12. So array of I is less than equal to array of j. So we simply update that into the result. That is array of I. Array of I is 3. So we update that into the result as 3. And correspondingly we are incrementing the value of I and also incrementing the value of k. So k point to the index 3 and I will come out of this left subarray, because if we increment it, it comes out of the higher index of this left subarray. So we come out of this while loop. We won't go inside this if in this while loop because I is not less than mid, because the value of I is incremented from 2 to 3. So this will be 3 and mid is 2. So it won't go inside this while loop, but it will go inside this while loop. Why? Because the value of j is mid plus 1, that is 3, and the value of high is also 3. So it will go inside this while loop and correspondingly update the result array. So what we need to store? We need to store the array of j, which is 12 in this case, and correspondingly increment the value of j. So these two operations are done. Result array is updated, and at the last we need to update the main array, that is this array. So in this subarray we store 3 and 12, so we correspondingly update the main subarray. At the index 2 we have 3 and at the index 3 we have 12. Now the left subarray is also processed and this right subarray is also processed, and as you can see this left subarray is already sorted and this right subarray is also sorted. Now we need to again do the merge operation of this two left and right subarray. So basically this is my first call for the left subarray which is processed, and this is my second call which is for right subarray which is also processed. Here the value of low is 0, the value of mid is 1, and here the value of mid is 1, that is 1 plus 1, this 1 plus 1, and the value of high is 3. So these two calls are processed and we get the left subarray sorted and right subarray is also sorted. Now time to call the merge method. So this is my merge call, where the value of low is 0, the value of mid is 1, and the value of high is 3. 0, 1 and 3, and we call this merge method. So in the merge call, here we have the I, j and k. So this is my I which is at the index 0, because the value of low is 0, the value of mid is 1, and value of high is 3. So the value of I is 0, the value of j which is mid plus 1 is at the index 2, and this is my k because the value of k is equals to low and the value of low is 0. Now of course I is less than mid because this is my mid, so I is less than mid, and j is also less than high. So this is my merge operation that is going on. So array of I is less than array of j. In this case array of I is 4 and array of j is 3. 4 is not less than 3. So it means it will go to the else part of it, and whatever value that is present on array of j, which is array of 2, which is 3 in this case, we update that at the index 0 in this result array. Why? Because the value of k is 0 and here we are updating whatever the value that is present at the array of 0, that is array of j. So we take this value that is 3 and update that at the index 0 of the result array. So here we update the value as 3, and correspondingly we increment the value of k and increment the value of j. So we increment the value of k and correspondingly increment the value of j. Now we again go back to this while loop and we check that the value of I is less than mid. Why? Because the value of mid is 1, the value of high is 3, so I is still 0, so 0 is less than 1, and j is 3, which is equals to the value of high, that is 3. So it will go inside this while loop. Array of I is 4, array of j is 12. 4 is less than 12, so we execute this instruction and store what is present in the array of I. Array of I is 4, we update that into this result. So previously here we have 8, now we update that with 4, that is this number, and correspondingly we increment the value of k and increment the value of I. So we increment the value of k and increment the value of I. So these two operations happens, and then we again check the value at this while loop. So I is less than equal to mid. So currently of course the I is equals to mid actually, and j is also equal to high. So we go inside this while loop. Array of I is 8, array of j is 12, 8 is less than 12, so we update the value here as 8 and correspondingly increment the value of I and also the k. So k will point to this index and I will again increment, so it will come out of this higher index of this left subarray. So it means we break this while loop, and once we break this while loop, I is already break that high index of this left subarray, so it won't go inside this while loop because the value of I is 2 and the value of mid is 1, so it won't go inside this while loop, but the value of j is 3 and the value of high is also 3. So we come inside this while loop and simply update the value that is present at array of j, which in this case is 12. So we simply update here 12. So 12 is already present anyways, but we'll update it with the same number. and then we correspondingly update the main array. So one by one we take all these numbers from this result array and then update this left subarray. So previously this left subarray was 8, 4, 3, 12, but once we do the merge operation of these two left subarray and right subarray, we'll get the result as 3, 4, 8 and 12. And how we get that? We get that from this result. So this left subarray is now sorted. Now we apply the same divide and merge approach on this right subarray as well. So in the left subarray, we apply the divide and merge approach and we get the left sorted array. Now we apply the same process into the right subarray. So it will also become sorted. So previously it has having 2, 25, 6, 13 and 10. And after the same approach, it will be sorted. And correspondingly, this result array will also get updated with this number. So if you see, this result array store the left subarray which is sorted and the right subarray which is also sorted. So these two calls are already written. It means from the first call, from the main method, this is the first call, this was the second call where the value of low was 0, the value of mid is 3 and this is 3 plus 1, that is this call, and the value of high is 7. So now we get the two sorted array, that is left subarray and right subarray, and then time to call the merge method for this left and right sorted subarrays. So this is my merge call. Here the value of low is 0, the value of mid is 3, that is this 3, and the value of high is 7, and we call this merge method. So 0, 3 and 7, and correspondingly we update the value of I, j and k. So this is my I and j. I is pointing at the index 0 because I equal to low, the value of low is 0. J is pointing at the mid plus 1, that is 3 plus 1, that is 4 at the index 4, and this is my k. So basically now we need to apply the same merge process that we just discussed now for this left subarray. And after applying this merge process, we get the final sorted array, and we store the final sorted array into this result array. So if you see, this result array is already sorted, and correspondingly as we need to update the main array also, so main arrays also get updated with the sorted elements. So if you see, in this particular merge sort operations, we are taking an extra space, that is O of n space, that is this empty result array, and we return this result array which stores the sorted numbers.